Yeah, welcome everyone to another FutureDAMS webinar. And today we've got colleagues in the FutureDAMS Research Consortium that are going to present some of their work on the implications of hydrodams for decarbonizing Ghana's energy, consistent with the Paris Climate Objective. And we've got Jaise and others here, but I'm going to let Emmanuel introduce the speakers and say a few words. But before that, just a couple of housekeeping issues. You should be muted. Please keep yourself muted. That way we'll take questions at the end of the presentation. But if there's any clarification questions that you have, then please put them in the chat box down there. I'll be looking at it. And if there's any clarification questions, we'll get to it. If not, we'll just do all the questions in the end. So yeah, Emmanuel, up to you.
Okay, thank you, Roshan, and thanks to everyone online today. We'd like to welcome every one of you, especially to today's seminar or webinar, which is focused on Ghana's energy situation and looking at how to deal with the emission levels that are currently the levels we have in terms of existing infrastructures, particularly the hydro dams, and how to decarbonize the current levels that we have in terms of our carbon emission. There'll be two important presentations that will be done. One from the work that Jaise is leading from the University of Manchester, which have taken a look at scenarios that are plausible options for future development for Ghana and the implications they have for carbon emission. And then our colleagues from the Energy Commission will also make a presentation that provides us information regarding our trajectory in terms of our energy sector development. Where have we come from? Where are we? And where are we headed to? And both together are supposed to provide us with comprehensive information on Ghana's trajectory in terms of the energy development, what options are available to the country, and how do we meet our Paris requirement in terms of being compliant to the Paris Agreement. So once the two of them have delivered these presentations, they are supposed to stir up some discussions. And we expect that everyone present online will make their own individual contribution, either from their individual experiences or from their institutional perspective to enrich the discussion. So both of them will take turns to present before we launch into the discussion phase. So once again, let me welcome all of you, and it's my hope that we enjoy this webinar and make contribution that will help to advance the discussion on Ghana's energy emission meeting Paris Agreement. Thank you. So I will invite Jaise first. So Jaise, please take your turn now to present to us the work you've been doing. And then after that, Laura will follow. Thank you.
Yeah. Okay. Thanks, Emmanuel. First of all, I would like to say thank you to inviting us to present our work on the implications of hydro dams for decarbonizing Ghana's energy system in line with the Paris Climate Change Agreement. So this work has got significant contributions from my colleague, Kevin Anderson, and the colleagues from CSIR, Emmanuel and Deborah. So the key question we asked in this work is to understand the potential role of hydro dams in Ghana's energy system within the context of a national emission reduction commitment and in a Paris compliant carbon budget. So in this presentation, I will start with giving an overview of Ghana's energy, then Ghana's nationally determined contributions and the Paris-aligned carbon budget. I will discuss the future energy scenarios for Ghana, the hydro resource potentials, carbon emissions from hydro reservoirs, and finally, some of the low carbon energy options before making the conclusions. So Ghana is a low middle income country in the West Africa. It has a population about half of the UK, roughly 31 million. And it has a land area similar to that of the UK. It's one of the fastest growing economies with a GDP growth rate of 5%. It is probably one of the fastest in the sub-Saharan Africa. It has got a per capita GDP about 12% of an average EU person, and about 85% of the population has access to electricity. In terms of final energy consumption and the electricity demand, it's roughly about 6% compared to the UK, about 100 terawatt hours final energy and 16.5 terawatt hours of electricity. For per capita electricity and per capita energy, that is about 12% compared to that of the UK's average person. So how does the energy use in Ghana? The hydropower contributes about 37% of electricity supply in Ghana. And in terms of the overall energy, the total energy, that's equates to about 7% of final energy consumption. There is a significant drop. 10 years ago, the hydro provided about 70% of the supply. Now that is down to 37%. All other renewables, excluding hydro, is only less than 1% of the electricity, and that's largely from the solar and some from biomass. As you have noticed so far, there is a significant increase in the use of oil and gas for the electricity provision, at least in the last 10 years, as you can see in the graph on the right-hand side. So the demand has been increasing significantly for the final energy, 2.7% per annum increase in final energy, that is the black line here. For electricity is also a significant increase, 6.7% per annum increase, that's the dotted line here, that's also increasing. And this increasing demand is supplied largely from natural gas, which you can see in this region. There's a significant increase in the use of gas in the last 10 years. The Paris Climate Change Agreement requires all the nations to outline their post-2020 climate action through nationally determined contributions. The NDCs are self-defined goals according to the country's national circumstances and according to the country's priorities. For a developed country, they can define a goal, they have to define the goal in terms of absolute emissions reduction. However, for the developing nations, it's purely up to them how they want to set a goal according to their priorities. So, for example, they can put a goal in terms of emissions per unit of GDP or per capita emissions, or in relation to a business as usual projection of their emissions. Unlike an endpoint target, as if in the NDC target, a carbon budget is a different framework, different way of approach in terms of setting a goal. So the carbon budgets are linked to a climate change goal of a particular temperature target, let's say it's 1.5 degrees Celsius or 2 degrees Celsius. This is because the emissions we release today stay in the atmosphere for a very long time, over 1,000 years. So it is not the long-term targets or the emissions in a particular year is not that matter. What matters is the emissions we release from now onwards, because that is going to stay in the atmosphere for very long term. So the carbon budget is the cumulative emissions, the emissions that released from now onwards. That's the total amount of emissions we release to the atmosphere. That's the area under the curve. So there are two emission reduction targets by Ghana in relation to their projected business as usual for 2030. The first one is the unconditional target, that is 15% lower relative to the business as usual. Then they've got an additional, another target called the conditional target, that is an additional 30%, which means a 45% lower relative to the business as usual. However, the actual emissions by 2016 is well above the conditional target of 45% reduction. In 2016, there was emission was at 42.2 megatons CO2e, compared to the conditional target in 2030, that is 40.67. Nearly half of all the emissions are CO2. The rest is from emissions, methane and nitrous oxide from agriculture waste, so on. So we then estimated a carbon budget for Ghana. That's for energy system. That's 397 megatons CO2. So this is estimated by allocating the global carbon budget from the IPCC special report for 1.5 degrees Celsius using the Anderson et al.'s approach. So in this approach, the total CO2 emissions, we take out the land use related emissions and industrial process emissions. So that means all the emissions, remaining emissions are for just energy. And this is then allocated to all the developing nations first. And then we use Ghana's recent emissions from 2015 to 2019, the proportion of Ghana's recent emissions to the developing nations to estimate the carbon budget for Ghana. I also compared this budget to the most recently released the IPCC Assessment Report 6 global budget. So that equates to a 66% chance of avoiding 1.7 degrees Celsius of climate change. So the carbon budget, the stylized emission reduction pathway related consistent with the carbon budget is shown in the green line, and the conditional and unconditional targets is also shown in the graph. We then developed 3 heuristic energy scenarios for Ghana: local, hybrid, and central. So the local scenario is a low demand scenario. So that assumes the citizens of Ghana will be highly engaged. So that means a highly efficient energy system. It has got a distributed energy system. There will be very few heavy industries, low urbanization, and high levels of IT. Whereas in the central scenario, it is a high energy demand scenario where the citizens are less engaged in the energy use. As it says in the name, the electricity system is highly centralized. There will be lots of large-scale heavy industries. The hybrid scenario is somewhere in between the local and central. So the demand will be somewhere in between. There will be some heavy industries, and there will be some level of citizens' engagement. To estimate the energy, so we use different parameters for these scenarios. For local scenario, we assume the per capita energy rises at 0.5% per annum from now onwards, from 2020 onwards. And also it assumes the population will be increased according to United Nations medium variant projections to 2050. So in 2020, the population will increase at 2.1%, and that will decreases, and by 2050, the population growth will be about 1.4%. To put that in context, in the last 10-20 years, the per capita energy in Ghana has increased very little. So this 0.5% is the kind of current trends in the last 10 years or so. For the central scenario, we assume that the energy demand will be increased at same as the GDP growth rate. So the GDP growth rate is 5%. So the energy demand will be rising at the GDP growth rate. For the hybrid, what we assumed is it will be rising at a 3.1% per annum. So that is the energy GDP elasticity to the GDP growth rate. So the energy GDP elasticity is 0.63 for the last 5 years. We then assume the bioenergy within the Ghana's energy system will be constant. So 57 terawatt hours in 2040 and 65 terawatt hours by 2050. That is based on the biomass resource availability from various literature. The petroleum also constant for all the scenarios, so 21 terawatt hours by 2040 and 2 terawatt hours by 2050. So that is to limit the use of fossil fuels so that the both the three scenarios are consistent with the carbon budget we estimated. The hydro capacity in the three scenarios. So in the local scenario, only the Pualgu dam will be added. So that is the dam under construction. For the hybrid scenario, Pualgu and another dam which is under planning, Hemang, will be added. And in the central scenarios, all the 16 potential sites identified in Ghana, in combination 850 megawatt will be added to the energy system. So from that, we estimated the final energy demand and electricity demand. So the final energy will be increased 2 to 4.3 times from the energy in 2020, whereas the electricity demand has got a significant increase, 8 to 22 times compared to 2020. So you can see in the graph the energy for 2030, 2040, and 2050. And the Ghana's National Energy Plan also has got two scenarios: the business as usual and accelerated economic growth scenarios. So that's also shown here in the patent. To put that in context, in the last 20 years, energy demand has increased about 1.6 times, and electricity only 2.4 times. So that you can see how much the energy and electricity increase has assumed in our scenarios. So to be consistent with the carbon budget, so that means there will be a difference in the electrification of energy by 2050 for all these three scenarios. So for the local scenario, the 66% of all of the energy needs to be electrified to be consistent with the Paris carbon budget. Whereas for the central scenario, 84% of the energy needs to be electrified. Now, if there is more biomass is available in Ghana, that means the electrification rates can be reduced. Hydro resource potential in Ghana. So at the moment, the total capacity of hydro in Ghana is 1,580 megawatt, mainly from the three dams, Akosombo, Kupong, and Bui. You can see here the Akosombo and Kupong here and Bui here. There is 16 major sites identified, which is shown here. The Pualgu Dam right at the top, the northern part of Ghana, that is 60 megawatt, that is under construction. And Hemang at the bottom here, 60 megawatt that is under planning. If all the 16 dams are constructed, that will generate approximately 11 terawatt hours. That is an additional 3.2 terawatt hours of electricity, which means roughly 4 to 6% of future electricity demand within the scenarios. The hydro reservoirs are also a major source of greenhouse gas emissions. The CO2 emissions are largely from the decomposition of flooded organic matter. So that is when you build the dam, it will be flooded, and the inundation of the organic matter means that release carbon dioxide, and also there will be some soil carbon, that the sediments flowing to the reservoir from outside. The decay rates of organic matter, which is flooded, will be diminished over time, and the principally last 10 to 20 years. So after 20 years, the only emissions will be whatever organic matter that will be flown into the reservoir, which is more natural. So the anthropogenic content will be in the first 20 years. The CS4 emissions is also from decomposition of organic matter, but that is mainly at the bottom part of the reservoir under the anoxic conditions of the sediment. The N2 emissions are small. They are indirect, largely from the surrounding managed land, from the agricultural activities, and that is not included in this analysis. The rate of all the emissions will vary according to the environmental and topographical factors. The morphometry of the reservoir matters a lot. Then the sedimentation rates, the amount of vegetation in the reservoir area, the trophic status, climatic conditions, all influence the rate of emissions within the reservoir. So we estimated the carbon intensity from all the existing reservoirs, and for the Pualgu, we used the GRES tool, which is developed by the International Hydropower Association, and also the general aerial flux rates from literature to estimate these emissions. And the carbon intensity is based on the reservoir used for the hydropower generation, because the reservoirs can be used for other purposes such as irrigation or flood protection. The GRES tool estimates are likely to be more accurate, because it uses site-specific variables, about 50 different variables, and we obtained those variables from the Ghanaian stakeholders for all the different reservoirs and also for the Pualgu. These greenhouse gas emission intensity are over for 100 years. So it assumes that it's the same for over the 100 years. So the previous graph was for all of the greenhouse gas emissions. So we also estimated specifically for CO2 only so that it is comparable to the carbon budget. As you can see, the emissions are the CO2 emission carbon intensity for Akosombo or Pualgu is very high, which can be comparable to a gas power station. Emissions, as I mentioned earlier, the emissions of the reservoir, they are not constant. The majority of the emissions happens in the first 10 to 20 years. So therefore, we derived what might be the emissions on a year-on-year basis for the carbon budget period from 2020 onwards. So majority of the emissions from the Akosombo, Kupong, and Buye, because it's already constructed much earlier, so that's less emissions. But the new dam Pualgu which is most likely to be completed by 2025, is much higher. So it's more than a coal power station. Typical carbon intensity for coal is about 900, and gas is about 400 grams CO2. So the emission intensity for Pualgu for the first 10-20 years will be much higher, and then it will be it reduces slowly. So based on this approach, we calculated the total emissions from the reservoirs for the budget period 2020 to the rest of the century. So for the local scenario, the total emissions will be 57 megatons CO2, and for the central is 141 megatons CO2. That is roughly 41% of the carbon budget for the local scenario, and 36%, more than a third, under the central scenario, which means if all the dams are built, then it will take more than a third of the carbon budget. At the same time, if we built all the dams, it can provide only less than 4% of the local energy scenario and less than 3% of the final energy under the central scenario. For electricity, all these dams can contribute just under 6% for the local scenario and 3% for central scenario. So that means, a very low contribution in terms of actual energy, but much higher emissions from these reservoirs. And so that's shown here in the graph as well, how much emissions it will contribute for Ghana. The new dam Pualgu itself is going to release 6.2 megatons CO2 in the budget period, and that is just for the CO2. There is significant methane emissions also from these dams, which is not part of the carbon budget analysis. But that is quite significant because for the Paris Agreement, especially for 1.5 degree target, significant release of methane in the short term has got much higher implications. The methane emissions are much higher in the Pualgu. That's because the area is being hyper-eutrophic. So what are the other low carbon options? There is significant bioenergy potential, including crops, residues, and waste. There is potential for 76 terawatt hours from the literature. Wind, there is low to moderate wind speed in Ghana. The potential sites around Greater Accra and Walter region. Ghana's got a coastline of 550 kilometers. And if we take to the outer sea about 40 kilometers, with an installed power density that's similar to a European offshore. If we assume the same power density, means Ghana can install 50 gigawatt of offshore wind in the sea, which equates to about 150 terawatt hours of electricity every year. Solar, it just got much higher daily radiation, 5.1 kilowatt hour per meter square. If we install PV in the existing reservoirs, including Pualgu, just 18% of the reservoir area, if we use that for PVs, that can generate about 300 terawatt hours. So that is less than 1% of Ghana's total surface area. So there are lots of opportunities from solar, wind, and bioenergy that can contribute all of the energy requirements for Ghana for 2050. So to conclude, the Paris compliant carbon budget for Ghana, about 397 megatons CO2. The energy scenarios for Ghana ranges from 196 to 427 terawatt hours. Electricity demand, 129 to 360 terawatt hours. The reservoir carbon dioxide takes 36% of Ghana's total carbon budget if all the dams are built. If no further large dams are built after the Pualgu, only 15% of the carbon budget will be taken by the dams. Our analysis suggests that a combination of biomass, PV, and wind can provide all of the energy requirements for Ghana by 2050. So low carbon CO2 power generation and high levels of or rapid electrification of the energy are fundamental for Ghana to meet the Paris Agreement. If failing to do this, that means the Ghana will be locked into high carbon infrastructure. That's everything from me. Thank you.
I think, Laura, would you like to share your slides next?
Hello. Oh, am I muted?
No, we can hear you now. Yeah.
Okay. So I'm presenting this on behalf of Mr. Salifu Ado, and the presentation is on Ghana's electricity situation, the role of hydro. So we all know that the demand for electricity in Ghana is a key determinant to our country's continued economic growth. Therefore, the country's power sector goal, which seeks to efficiently supply power in an environmentally sustainable manner that adequately meets power demand whilst being a major net exporter in West Africa. So currently, the situation now, currently we have an electricity access of 85.33%. So about 85.33% of the population in Ghana have access to electricity. And this commitment, our commitment to universal electricity access is to attain the universal access by 2025. But this way started in 1989 when we only had access to only about 15 to 20% of the population had access to electricity. And through programs like the Self-Help Electrification Program and the Ghana Electricity Access Program, the improvements in the access has been attained. To our current demand, Ghana has experienced an increase of about 105% in peak load over the last 10 years, increasing from about 1,500 megawatts in 2010 to about 3,090 megawatts in 2020, translating into an increase of 7.5% annually. Generation capacity, on the other hand, has more than doubled over the same period, from about 2,165 megawatts in 2010 to about 5,288 megawatts in 2020. So currently, that's where we are. But in terms of the installed capacity, we have a total installed capacity of 1,580 megawatts. But in 2004, when we had Akosombo and Pong alone, we had a total of about 1,180 megawatts. The addition of WE in 2013 increased the total hydro installed capacity further to the 1,580 we have currently. So our great electricity generation sources are mainly hydro and thermal. Though the country has some generation from renewable sources, steps are currently being taken to improve the generation or the amount we get from renewable electricity to diversify the mix. Also, there has been significant generation capacity over the years to ensure that the growing demand is met. So the total annual electricity generated in 2020 was about 20,230 gigawatt hours. Though the installed capacity for hydro has increased, generation has been fluctuating because of water inflows. In 2010, the share of electricity generated from hydropower sources decreased to about 36%, whilst that of thermal increased to about 63%. Out of the total, only about 0.3% came from renewable generation sources. So our current situation as to what we expect to have by the end of this year. The estimated energy supply for 2021 is estimated at 21,265 gigawatt hours, out of which the supply will be from 3 sources: hydro, thermal, renewable. So it's estimated that we have about 33% from hydro, 66% from thermal, and 1% from renewable. The fuel used by the thermal plant is estimated to be gas and HFO. And looking into the medium term, that's the next 5 years, what we expect to have as a country. Okay, so the total electricity requirements for Ghana, including power export to Togo, Benin, Burkina, and Mali, is projected to increase from about 22,800 gigawatt hours by 2020. Yeah, hello.
Sorry to interrupt you. I think your PowerPoint is not moving. Yeah. Sorry. Yeah. There we go. Yeah.
I think I'm here. Yeah.
Yeah.
Okay. Thank you. Sorry for that. So the total electricity requirement for Ghana, including power export to our neighboring countries, specifically Togo, Benin, Burkina, and Mali, is projected to increase from about 22,700 to about 28,500 gigawatt hours by 2026. The domestic share is about 92%. And the figure showing on your slide now shows the trend for the next 5 years. So we move on to the power demand. The power demand is also projected to increase from about 3,500 megawatts to about 4,600 megawatts in 2026, having a domestic share of about 90 to 92% over the period. So in terms of capacity requirements to meet demand, it's projected that hydro would contribute to about 43% of the demand in 2022 and 43% of that in 2026. The deployment of committed generation capacities would be adequate to meet projected demand, including a reserve capacity of 18% up to 2024. We are looking at additional generation capacity from 2025, specifically maybe 51 megawatts and 392 megawatt additional generation capacity, which will be needed by 2025 and 2026. Also, Palugu hybrid hydro and solar plants is expected to come online and to be commissioned by 2025. In terms of resource potential for hydro, currently the 3 dams have captured much of Ghana's hydro potential, but there is still some significant potentials that could be harnessed through a few dams, mainly in the Volta Basin, TN Basin. The 3 planned dams that are high priorities for the country and for VRA, that's the Volta River Authority, includes the Herman, which is about 83 megawatts, Palugu about 60, and Joale about 100. Currently, the Palugu multipurpose dam is under construction. So in terms of the role of hydro in emission reduction, the analysis showing on your screen is focused on emissions from combustion of fossil fuels. Emission from water and sun for hydro dams and solar are assumed to be 0. The energy emissions from the production of electricity show the general rising trend with a notable dip in 2015. The increase in CO2 emissions were driven by emissions associated with electricity generation, particularly with high carbon intensity thermal generation. The avoided emission is shown as the gap between the 2 series. So the one below is the emissions we have from thermal for the past 10 years. And the above one is the potential emissions without hydro. So assuming we are using thermal instead of hydro to complement what we have now, those are the potential emissions we could have gotten. So the gap is showing the avoided emissions and between the 2. So, okay, challenges. Okay, we all know the environmental impacts of dams. We all know that dams can have both adverse and beneficial environmental impacts. Despite the huge benefits of the dams, the deployment of dams have been at a high cost in terms of livelihood and environmental ecosystem degradation. The construction of dam itself contributes to degradation of its catchments. For example, extraction of cocoa for by a labor force and improved access to the forest, both during and after the construction of dam, degrades the environment. And the conclusion, we know dams are important in the water, food, energy, environment megasystem that can help deliver economic growth and sustainable development. Also, dams, Ghana has 3 large dams, as mentioned earlier, that serves the purpose of hydropower generation, domestic water supply, irrigation, and fish production. The country has a potential in small hydropower and renewable energy sources, which when fully exploited, would bring diversity into the country's generation mix, thereby curbing the dependence on Akosombo and the major thermal generation facilities. Also, the role of renewable energy in achieving electricity self-sufficiency cannot be overemphasized with that. And I think that's the current situation and where we aspire to be in the next 5 years. Thank you very much.